Well, welcome to the video. This will be the solutions to the practice mid-unit exam for Unit 8. And I am going to try to go through this as quick as possible to try to fit in as many of these problems in one video in my 15 minutes that I have. So let's get started. So here's number one. If I skip some things, skip reading it, bear with me because I'm trying to get through all of these. So we're trying to find vector PQ, and vector PQ, Q is going to be our terminal point, and P is going to be our initial point. So we're going to go P to Q. So the way we're going to do that is we're going to subtract the y value, subtract the x value. So our PQ, our vector, is going to be 4 minus negative 1, which is 5, and 5 minus 2, which is 3. And RS is going to be 5 minus negative 2, which is 7, and negative 6 minus negative 2, which is negative 4. Okay, this is find, I should have double lines here. This is find the magnitude of this vector. So we're gonna multiply PQ by 3 and multiply RS by 4 and then subtract them. So let's go and do that. So 3PQ is, we're gonna multiply, man, my pen just doesn't want to work today. Multiply this by 3, so that's going to give me 15 and 9. And multiply RS by 4, and that's going to give me 28 and negative 16. And then I'm going to subtract these, so when I subtract them, I'm going to get negative 13, okay, because I got to go this minus this, and 25, and then I want to find the magnitude of that, so I'm going to take the square root of x squared plus y squared, and that's going to give me about 28.18. So with these you can use the calculator. You'll be able to use the calculator on the test tomorrow. Direction of this, so again we got to multiply PQ by 2 and RS by 3 and then find the direction. So first I'm going to go ahead and do the multiplication. And when I multiply this, I'm going to get 10 6. And I multiply RS here, and I'm going to get 21 negative 12. And again, all I'm doing is using the ones that I had from part A. And I'm going to add those two together and get 31 negative 6. And I want to find the angle this is. So 31 negative 6 is going to be somewhere, down here. Because I'm going to go 31 down 6. So I'm going to use the inverse tangent. And I'm going to use the inverse tangent of y over x. And this is going to give me an angle of 10.95 degrees. And that's right in here. So this angle is the one I'm talking about. So if I want to describe that angle, I want to make sure I describe it as negative 10.95 degrees. All right. You can also say this is if 360, if we start here and we want to go all the way around, then we would subtract from 360 degrees and we would get 369.05. So you can also say that 300 and 360 is 349. Sorry, 349.05 degrees. Okay, so these are two ways you could describe that angle. So just don't leave it like that. Make sure you do it the correct way. Let's take a look at the next one. So we've got the word problem here, and I'm going to draw my vectors. So I've got one vector that goes like this with a bearing of 60, so that means this is 30. And the other one has a bearing of 45, which is right in the middle. So my first vector, I'll call that vector of the airplane. I'm going to find the x for the airplane, which is 580 times the cosine of 30 degrees. And my y for the airplane is going to be 580 times the sine of 30 degrees. And that's going to give me 502.3 and 290. And I'm going to find the x and the y for the wind. Cosine 45. Y for the wind Okay, 60 sine 45. And that's going to give me 42.4 for each of these. Then I'm going to add the x's together and then add the y's together and put them together to give me my resultant, which in this case is going to be the true bearing and the true speed of the plane. So I'm going to add those together, 502 and 442, and get 544.7, and add 290 and 42.4 and get 332.4. So now I have my resultant in standard form. I need to find the magnitude. So I'm going to take the square root of x squared plus y squared. And that's going to give me a result of 638.1 miles per hour. Okay, so this is the true speed. Now I want the true direction. Now notice here these are both positive. So if they're both positive, I'm going to be in the first quadrant. So when I do my inverse tangent of y over x, that's going to give me an angle of 31.4 degrees. Now that angle is the angle right here. This is 31.4 degrees. But I wanted my bearing, so I really want this angle here. So I'm going to subtract from 90, and my answer is going to be 58.6 degrees in bearing. Okay, and that's how I'm going to label it. You know what? It doesn't matter how many of these vectors. I mean, I could add another wind. I could have planes. I could do this all over the place. And it's just the same thing every time. Take one vector, find the x and y. Take another vector, find the x and y. You could take another vector, find the x and y. Add all the x's together, add all the y's together. And then once you have the resultant, you just do this stuff here. Okay? So if you have multiple of them, you want to be able to do... You're just going to add them. You're going to add the x's and add the y's. Okay, same thing. Let's take a look at the next one. Eliminate the parameter. So for eliminating the parameter, I suggest you eliminate the one that has the non-square in it, the non-power, and then plug it into the other one. So here I'm going to add 4, and then divide by 2, and solve for t. And then I'm going to take this and plug it in here. And I'm going to get y equals 3x plus 4 over 2 squared plus 1. And I'm going to bring the 2 out here as a 4. So 3/4 x plus 4 squared plus 1. And this will be my answer. Okay, so this is rectangular form. All right, let's look at the next one here. Sketch the curve described by this parametric equation. So the only way we did it in this class was to use values for t, and we're going to start with our lowest value, which is -2. Then we're going to go -1, 0, 1. We're going to plug -2 in here for t, and when we do that, for x we're going to get 7, and for y we're going to get 4. And I'm just going to go and fill these in, so make sure you plug them in and check to see that you get the same answers I do. Then we're going to graph it. So on our graph, we're going to go 7, 4, 1, 2, 3, 4, 5, 6, 7. Now this point's going to be right there. 1, 3, so 1, 3. -1, 2. And finally 1, 1. Now 1, 1, this is an open circle because of that less than. So 1, 1 is going to be there. I'm going to put an open circle, and I'm going to connect these. I know this is a parabola because of this squared here. Okay, so that's that one. All right, moving on. We've got this pumpkin launch problem here, and these are our formula. These are our parametric equations. So we're going to determine when the pumpkin hit the ground. Well, it hits the ground when this is 0. Y is 0, right? Because it starts here and it goes down. The y value is 0 because y is the height. So we're going to plug in 0 for y. And we're going to solve for t. Now you can use any method you want here. I used the quadratic formula, so -b plus or minus b squared minus 4ac over 2a. Or you can use a calculator and find out where it hits the thing. But either way, you're going to get a t value of 5.8 seconds. So you need to use a calculator for this, okay? And I suggest using the quadratic formula. And then once you know what the time it takes to hit the ground, you're going to plug it into X, because that tells you how far the cannon goes, or how far the pumpkin goes away from the cannon. So you do 88 times 5.8, and you're going to get about 510.4 feet from the cannon. So what does this look like? Okay, if you sketch the graph of the pumpkin, well, the pumpkin's going to start at 25 feet, and then it's going to be launched, and then end up landing here at 510 feet. All right, so this is the path of the pumpkin. That's pretty much all you needed to do there, okay? All right, let's look at the next one. Determine the parametric equation to give you a line segment. So this one's a little bit trickier. You need to find a line segment. Now, a line segment, you know, is going to look like this. So the only way that you're going to get this line segment is to have values of t that restrict your graph. So you're going to need to find those values of t. The easiest thing to do is to first find what that whole line would be and then restrict it. So the whole line, well, we're just going to use, you know, what we normally do to find lines, and we'll find the slope. The slope ends up being -1/2. We'll put it into our slope formula, our point slope formula. So y minus y1, y plus 2 equals -1/2 x minus 4. When I solve this, simplify this for y, I get 1/2 x. So now I'm going to convert this into parametric. So to convert this into parametric, I'm going to say x is t and y is 1/2 t. And then I have to restrict this. The easiest way to restrict this is just to start with this x value. Okay, so that's got to be 4. And then this x value, which is -2, as t. Okay, so my restriction is going to be between 4 and -2. And that should work. If I plug -2 in here and -2 in here, I should get my point 1. If I plug 4 in there, I should get my y value, which was -2. Oh, -1/2. Sorry. Okay, so this is your whole answer. You have to state not only the parametric equation, but the restriction on t. All right, I think those were all the problems. So if you have any questions, put them in the comments, and I'll see if I can get back to you as soon as I can. Thanks. Bye.